Hello everyone, it's Michael Mechanical. Today I just took delivery of 2 more of these gaskets because I'm going to send one off and have the shim refitted into one. And I'm going to install the other one, which is only just out of spec for this, but it will be okay because the pistons are lower than before. I've made mistakes. I accept that I make mistakes, except I'm not perfect. But the difference in my situation compared to everyone else's is that I haven't been in the right mind space to do this job properly. That being said, I'm trying to take this slow, I'm trying to take this easy, I'm trying to do it at the pace that I wanted to do it at. You can't do a job correctly if you're going to rush it. And that's sort of what happened when my motor broke. And the only reason that broke is it probably had damage from prior in which I didn't actually notice, because I know what normally happens when you have piston valve collision. Normally it breaks the rocker arms. Well, in this case and scenario, something else happened, and I'm not sure exactly what, and until I pull it apart and inspect everything from the pistons, top of the pistons, to the valves, to everything in the head, I'm not going to know what happened. But one thing I've recently learned that no one can tell me otherwise is that head has been shaped too many times and was never actually suitable for that engine. There's one reason I know that's a fact. I kept having piston valve collision regardless of anything I did to change it. I added a thick gasket for all the materials removing from the head and the pistons, but unfortunately I still had piston valve collision. It was only lightly touching, very light. So it was either in the higher rev ranges, in which could be why I've actually broken the top end, or it could be something entirely different and not related to that at all with RPM. In this case and scenario, I will tell you for a fact, I know, by looking at these valves, they are really heavily recessed by 1 to 2 millimeters there. And on mine, they're almost flush with the head. I don't know for certain what they were, but I do know that my valves were protruding much more than those valves were. The question is, by how much? I don't know. And that's the thing, I got told that it was okay, that the valve protrusion is perfect for that head, it's fine, there's nothing wrong here. But somehow I kept ending up with the piston valve collision, and I don't know why. It was just light on 1 and 2 and slightly 3 and never touching 4. It's like as if the head was machined on an angle, bringing the head down, or maybe even the deck or something, but all the pistons were about equal protrusion. So what's changed? The pistons all had the same protrusion values, so what's changed to cause 1, 2, and 3 to have even the slightest impacts, but 4 not to? The only thing that I've been told by someone is that the head's been machined on an angle. Like you're taking too much off the front and not enough at the back. Like you have 2 parallel surfaces, but at the front it's like this, and at the back it's like that. And that's how they can bring the valves close to the piston. I also got told potentially, if your pistons have worn out bearings, there might be a slight amount of play letting them, go up further and hit the head or hit the valves, but it's never hit the head until maybe now, but we'll find out soon enough. So that's a question of why did that actually happen? Is it because the head wasn't machined parallel, or is it something else? See, I might not be a professional, I might not be super duper perfect, but I do know for a fact I'm just as bad as every one of those other mechanics out there who make mistakes. The only thing is, in my case and scenario, I'm not getting paid for my time. I'm spending money doing the thing, and I'm making mistakes along the way. And I think it's good to show the fact that I'm making mistakes. And it's good for me to speak up and say that when I've had jobs done by professionals and paid money for a professional to do it, that they've made mistakes. And I feel like it's reasonable and sensible to show that, yeah, even someone as experienced as I am with even the paperwork to say, here's all your values and how to do stuff and assembly and stuff, I can still make a mistake. And to show why those mistakes happen is also good, to show that, hey, the reason I made this mistake is because I wasn't in the right mindset. And I was trying to rush this job. And when I rushed it, I wasn't happy, so I went backwards to go forwards. And then I found another problem, so I went backwards to go forwards. And in the end, it just makes you a little bit better for it, because then you realize, you shouldn't, no one should, if their head's not in the right mind space, they shouldn't touch it, because it's very expensive to go backwards and forwards all the time. Imagine if you were actually getting paid time to do that. You're paying to pull it apart again. You're paying to put it back together again. And then you're paying to pull it apart again. And then you're paying to put it back together again. In reality, that's just not viable for a business to do. They've got to do it all in one shot, essentially. Pull it apart, fix everything that needs fixing, and put it back together again, and don't stuff up along the way, essentially. But as people should know, in the real world, mechanics do miss things. They do actually make mistakes. And people can look at me and say that I'm not a professional. No, I'm not a professional. I've already said that. I've got a certificate in automotive. Doesn't mean I'm a professional. I've got experience. That's different to being a professional. I haven't been trained by professionals. Personally, I've learnt from experience. And I've been learning different things, and different things have been changing between scenarios. Every time something happens, something new shows itself. And I learn something new about this situation every single time, and I learn to reassess things in a different way. And I learn that I can't work when I'm under pressure in the sense that I need my own stuff now. I probably could in another sense, like do it based on someone else's work, because in that scenario I'm not rushing to get my stuff done, because if I need to go pick up parts, I can do it with my vehicle. If I need to order parts, well, they're just going to have to wait until those parts arrive, or try to obtain them themselves. Because, hey, if the customer wants to complain about parts taking too long to come here, and it's their equipment, ask them, would you like to go and try and obtain these parts? These are the part numbers, these are the part information. Would you like to try and obtain them? That's what you need, and this is how long it's taking us to get them in. We can cancel our order, and you can have your stuff back, and then you can fix it yourself. Because then, in a way, you have the power to say that. Because if you want this job done right, this is what we're doing to do the job right as a business. As a person, I don't want to make mistakes. But unfortunately, I'm going to do it anyway, because I'm still learning, and I'm still understanding myself. I'm still understanding the situation and various different things. I don't actually want to pull it apart any more than I've already have. I've got the sump back off again. I don't want to pull this all off. Now, if I really, really had to pull it all apart, I would have to. And then I'd be upset because I'd have to make that gasket again, because I didn't buy an actual gasket kit for all these gaskets. And even if I did, they're expensive kits. Here, look at the pistons. They're all nice and shiny. They're almost mirror finish. In fact, they are a mirror finish. They've been polished. And some of them actually do have some scratches in it. And I keep getting told those scratches will lead to cracks. And they're not so bad now, so I'm just like, no, I've had enough of trying to sand them. I think they're fine. Those scratches, you can't even see them until you polish the piston. And it's no different to how they manufacture the pistons with, those been imperfections. It's like, well, I've polished this far. They're close to mirror finish. There's not many scratches, and you can only see them when you use the few thousand grit paper. I'm going to leave them. They're not as bad as before, so the better they are, the better it is. The good thing about polishing those pistons, apparently, is that the carbon's going to have a hard time sticking to those pistons. Meaning, you pull it apart and you wipe them and they're still, mirror finish scenario. That's exactly what you expect to see. And the mistake I made with putting this engine together, the reason I shouldn't have put it together in the first place, the way I did, is because there was a few mistakes. One, I didn't know I could buy the connecting rod bearing for the top end of the conrod. And because of that, when I found the part number, that's when I was like, oh crap, I didn't know I could buy that. So I went out and bought the new bearings for the connecting rod up the top. Then I took it to the machine shop, he machined them, and I paid him good money for it. And he said he had to take 8 valve off. I got those connecting rods back, and there's like a little bit of silver inside of them, and the bronze that's meant to protect them and be good, and like a lubricant or something like an anti-seize or something, anti-wear properties it has, and some weird shit. I can't remember the exact details, but essentially, I looked at it and I was like, I'm not sure if I can use these or not, but he did machine them and he did give them to me and he said they're all good. So what did I do? I asked the next person I know with experience, my dad, for his thoughts on it. And the first thing he pretty much said is, no, they're no good. Because you want the bronze there. You don't want to lose the bronze. Once you've got no bronze, that's it. The bearing's no good anymore. So here's my case in point. There you go again with another freaking mistake. There's 2 mistakes there. One, apparently I ordered the wrong parts, but I got them through Sprints and they ordered them for me for what I thought were the right parts, but apparently they weren't. Apparently they were right, but they were wrong, and I don't get how that works because they looked at my engine, my VIN number, everything, and they picked the parts based on that, and that was the only listing I had. So what the hell happened there? And then this guy, I had to pay him yet again to do the bearings again, and I had to pay him for the parts to get the new ones in. From there, I put the engine back together again. I did not double check the protrusion values of the pistons. But, based on what I know, the pistons in 2, 3, 4 went up higher, and piston 1 went lower. That's exactly what happened, and that's why you look at this piece of paper and you see the values. Once I made that mistake, once I realized I made that mistake, I thought it was going to be fine, because I was cheating, and when I cheated, that wasn't good for me, it wasn't good for the engine. That's why I've gone backwards. Because I didn't even know about the thing where you should check it every single time something changes in the bottom end. I figure you replace a bearing and then it's back to normal. You replace this, that, it should all be square, right? No, it's never always perfect, especially when you have something machined. You can say I'm not a mechanic, you can say I'm not this or that, but the point I'm making right now, and it's clear as daylight, anyone should be able to see, is that the guy, he machined these 3 pistons to be up higher based on the bearings positioning, and that one to be lower. How does that even work? And I had him do the job twice, because the first time he said they're all good, and they were not. They were over-machined, and those bearings were not suitable for the application. They would have seized, they would have destroyed this engine. That's what my dad said. They destroy the engine because you want that coating there. Once that coating is gone, that's it. They're no good. That engine's going to fall apart. Then, the second time he made a mistake was machining those up. They're not square. They're not perfect. That one's off. Those 3 are off. They're not at the original height that was set, which was about 0.86 maybe. I actually don't remember what it was. But I'm pretty sure it was like 0.86. And these are the original values. So you have 0.72 and 0.78. So that's close to the original value. And then the other ones have just gone higher. So there you go. Cylinder 1 stayed about the same, and the other 3 went up. How does that work? It's baffles me. Because I took it to professionals, and they still make mistakes. So, regardless if I made a mistake or not with my own engine, I've already just pointed out another mistake, and it wasn't even my fault. I gave it to professional, paid a professional. He made a mistake, had to pay for it again to fix, 2 different mistakes. And then I got left with another mistake and I didn't even realize it. Now, here's the next thing I'm going to make a point on. Regardless if I say he made a mistake or not, I still made a huge mistake. I didn't double check those values. I didn't try to set the values, because what it says in the manual, it does say it in the manual, to essentially swap and interchange parts until all the values are the same. Because the connecting rod bushings changed, I don't have extra connecting rods with new bushes in them. So that wasn't going to work. And even if I did, these ones do not have new bushes in them. They're old bushes, and I'm not going to use the old bushes. I'm going to use brand new parts where I can. So there is mistakes from me, there's mistakes from the machine shops. And here's the other point I'm going to make. The original machine shop that machined this engine, he's a jerk because he did not clean the block very well. In fact, he didn't clean it at all. He said it was full of mud. He could have asked me if I wanted it cleaned perfectly or whatnot, or even say, hey, I've got to charge you more to clean this perfectly. But he didn't do nothing. He just finished the machining job and then he tells me, oh, it was full of mud. He didn't call me up to tell me nothing about the mud in the block. I go and I put a hose through the thing and I'm getting huge flakes of rust coming out of it. That's a machine shop I won't go back to, because that's not the first time I've had an issue with him, and that's not going to be the last. The last time before this one, and he validates my dad on all the bull crap. So when I'm experienced, I was going to say professional, but I'm not a professional. When I'm experienced, this freaking jerk who once upon a time told us if there's a crack in the block or the head or whatever, he'll point it out or something and it's no good. But he once swore at me and had a go at me because I asked him a simple question. How do you know that there's nothing wrong with that head? They said they wanted you to pressure test it, and he's like, look here, effing kid, this is how you know there's an effing problem with the effing head. You look here and you see if there's any cracks in the head, like between the cylinders. Right, look at this one. He looks at that and he's like, oh, I'll be right, mate. She'll be right, mate. This head warped real freaking quick on that engine. That head was no good from the get-go. And even a professional who's RAA approved, anyone who knows who the RAA is should know they are a reputable company. RAA have approved this repairer who doesn't specialise in engines, he specialises in transmissions. And he comes along and he takes one look at the head and he hears the story and he says, no, you should never have used that head again. Whoever your machine shop is, he's not very good at his job if he tells you to use that head. If he machined it and said you can use the head. I wouldn't have used the head, he said. I would have gotten a new shell and put all your good bits in there and bought whatever you needed to fix it. That head, no good. He said, nah, wouldn't have used it. I told my dad I wouldn't use that shell. Get a new shell and put a new one together, and then it'll be fine. No. So, some professionals are good and some professionals are shit. And I have to say it with a lot of emphasis because there's one guy who's saying stuff at the moment, and I couldn't be bothered with what he's saying because he's getting angry at me for making mistakes. And he's telling me not to do this stuff anymore. The thing is, the real lesson in life is you learn from your mistakes. You make a mistake and you learn from it. Why did it go wrong? How did it go wrong? And how can you do better next time? Next time, if I'm in this stressful position, hopefully I won't ever be in this stressful position again. But I've been planning for this for a very long time until I friggin' ended up back where I didn't want to be. Okay? The reason I kept this going for so long and pushing it was to buy me enough time to do this as calmly and contently as possible. So when this is done, when this is built, I was planning to just swap that motor with that motor, pull this one out, leave it running and ready to go if it can run. If something went wrong with this one while it's in operation, I can just swap them back out again and keep my car going, figure out what went wrong there, and go. And with this engine over here, in this car, the only thing that went wrong with that was the things that my dad checked. The things that my dad approved. He's a professional in his industry, he's got the qualifications that I don't have. In fact, his qualifications in some ways is that higher than a mechanic. Because he's a qualified tradesman. He used to make dies for making plastic injection molding. He told me how to polish up my pistons. He said you can do better than that. He criticised my job. You can do better than that. He said you can buy diamond grits of like 5,000, 8,000, whatever grit you need, you can buy it. That's a diamond grit. And you'd use that to polish it to a mirror finished, or even better. He's the one that told me that in the industry, ROH, who make mag wheels, they said they won't take any bars from them unless they are mirror finished, because if there's a scratch in there, that is the point at which this bar is going to snap under load. And they don't want any weak spots in the bar, so they want the scratches removed. Like my pistons, they have scratches in them. They wouldn't approve those scratches, apparently. And this is a mag wheel company. But they were talking about heavy stuff. This here is not heavy, this is combustion. This here is taking pressure and pushing down that piston down. And the likelihood of those cracks turning into something serious are minimal. In my eyes, it's minimal. Because what we normally do is, I don't care what anyone's saying, they'll turn into cracks. The reason I'm saying they will not develop into anything serious is not because there's scratches. It's because whenever we get the pistons in there, we normally get a scribe, and then we scribe into the pistons, and we actually intentionally put scratches in it. While they're controlled scratches, a scratch could develop into a crack. Well, we just scratched the pistons, didn't we? And we've been doing that a lot with the engines we've worked on, and I haven't seen anything go wrong yet, but, you know, it's only in the short term that we haven't seen nothing happen, not in the long term. This here should last long term, and where we normally see cracks in all of the pistons that we ever see is roughly here in this spot. That's the weakest link, right there. There is no scratches there. And that is where they're going to start letting go when they do start letting go. They're the weak spots. Don't believe me? Let's pull that one apart and let's go and have a look. But for today, I'm getting this engine back to where it was before. I'm going to put the oil pickup back in the engine at the bottom end. I'm going to put the gasket back on there. I'm going to blow up the bottom sump seal, and I'm going to do roughly what I did before, but a little bit different. And I had to sand this a little bit because you can see there's a little bit of paint in there. I think screw it, because the little chips of paint are going to go through the filter. The filter's going to catch them. It's going to be fine. And I'm just making sure there's no loose paint, so when it does go together, it'll be okay. And then I'm going to just put some glue on there, put all the stuff on there, tighten it up as soon as possible. I'm going to max the tension out on those bolts because, unfortunately, even when I put the sump on, there wasn't even enough glue on there the first time I did it. And I had some spots where the glue was coming into the sump. And what I have to do next time is I have to try and, I don't want to put glue over the bolt holes, like where the bolts actually go. And that's what I didn't do. I put it to the inside, and then the glue went onto the inside. So what I have to do this time, is literally go over the bolt holes, which I didn't want to do. But this time around, what I'm going to do differently is when I do put the sump on, I'm going to get the air compressor and blow out all of the holes. Because what I'll do when I blow out the holes is I'll make sure that those holes are not full of glue. So when I do bolt it all down, the glue is not in the hole to change the tension, and then it can go down to torque. This sump is a little bit bent and warped, but that glue is so strong it made me bend that sump. It's actually the same glue as on that sump there, but I think that's a lower grade of the same glue. I can make mistakes. You can make mistakes. Anyone can make mistakes. So I'm accepting responsibility for my mistakes, and I think, you know, I'm not having a, yeah, she'll be alright attitude. I had that attitude because I was in a position where I felt under pressure, and then later I reassessed and I got upset with my own work. I wasn't happy with it. I went backwards. You know what? I'm proud of myself for making that decision to go back and fix it. Not to just push it, put it together and actually destroy it. It would have been worse consequences if I put it together and it fails. It would be better to do that than to go forwards. I rectified a mistake. I'm rectifying mistakes that I've made. And there is a mistake still in there, but it's minor to the point. Even my dad said it should be fine because the pistons are not in a position where it's going to cause any major issues, which is a good thing. The rings are not in a major position where it's going to cause any issues, which is a good thing. And I've had rehoned the block. I rehoned it by hand to fix it as best as I could. I'm happy with it. To some extent, I'm happy with it. But unfortunately, I want another block if I'm going to do another engine. Because otherwise, I changed the cylinder liners and I put it back to stock standard because I don't like going bigger and bigger and bigger. And those pistons, you can, there's a slight amount of play, but they have a certain amount of play. I didn't hone the crap out of it to remove material. I honed it to fix those little imperfections in those surfaces. Nothing ever comes out perfect. You just have to try and do your best. And I do want to do my best, and I do want this to come out good. I do want this to be reliable, and I want this to last. I don't want to ever have to do mechanical work on my own car again, unless it's off the road and I have another car to drive. Another car that I can enjoy. If I don't enjoy this car, then I don't enjoy it. But I do enjoy driving this car. Next up will be the gearbox, which is the spare ones there. I didn't buy spares for nothing. I bought the spares to be prepared and to get ahead of problems before they occur. So when they do fail, I can just swap them out. Problem solved. I get my car running again. I do it as quickly and efficiently as I can for myself because I can't do that for anyone else but myself. I'm in the position of power where I have multiple blocks, I have multiple engines, I have multiple transmissions and transfer cases. Something goes wrong, you can swap it out. That's also what someone showed me a video of. Someone swap out your dong, Here's my ute, I got a dong on the back, you never know when that little gearbox is going to fail, so when it fails you just rip it out, swap it out, and away you go again. When that engine lights go, you just swap it out, put it, get it running again, and you're good to go. Don't go on long trips because, man, without an engine spare, things going to go wrong. That's pretty much what the video was implying with what it was implying. Okay, so I'm allowed to make mistakes. Anyone is. The first time I ever made a mistake that I wasn't happy with my work, and it was the worst ever, was this spot right here on this fairlane. That's why I stopped working on the car. I tried to do some work on the front, never came out perfect, still struggled with it, but eventually down the line, we learned a fact, and people are going to tell me I'm wrong, but the fact of the matter is why things kept going wrong when I was welding up those panels back then when I was a little kid working on the car was because the welder is high tensile. It needs to be a gas welder to do what I was doing. And there you go, you have your MIG wire stuff. Don't have the gas in these bottles, and they're not the right gas. There's your gas fitting. It has a high tensile wire inside the welder. Not suitable for what I was doing. You use a lower grade of wire. That high tensile is good in structural areas in certain conditions. You have to know what you're doing. You can't just do that job. That's what some people have done, and they've learnt from their mistakes, and they're actually pretty good at what they do, surprisingly. But I've seen worse welds than mine, and I've been told my welds are crap, but someone else came along and actually said, that's a friggin' really good weld because it hasn't let go in so many years. It might not look like it's perfect, it might look like it's overdone, but man, that weld's held up. My neighbour down the road, he has a weld on his gate, and I did the weld. I put his plate on that he wanted me to do it. I did an inside bead, a couple of beads, because you had to fill it, like gussets, and then I did the outside, and then we cold gouged the thing. The plate is bending, but the weld is not cracking or letting go, and it's mild steel to galvanized. It's a heavy plate, but it's not that heavy. In my eyes, it's a light, thin plate, but it's strong. But it's been holding up. This is probably the right material he should have used on his gate, but he didn't have any of that. Anyway, I better get going and get this thing done because I've got to put the sump together, and then Dad's going to help me put the head back on when I'm ready. I'm actually not going to put the head on until I talk to Dad about there's some minor scratches in the head, and those MLS gaskets are very fussy. I'm just going to chill out because I would rather take this to a machine shop and machine it again. And I feel confident in the head because the head's not actually scratched. It's got impression marks in it. Okay, there's a few scratches around the place, but they're not in vital areas. I've been told what to look for, what not to. There's the impression marks around the cylinders here, but that's just from the gasket. And then there's a little scratch over there, but you know, I talked to my dad about it and get a second opinion. He's the engineer. He knows what he's doing. He knows how to remove material or flatten material without scratching things up and keeping things level and square. He's done it. I'm going to make it as clear as I can about how professional my dad is, because people might think he's not as professional as I'm making out to be. Because when you go and tighten up bolts and when you do work on cars, okay, it's going to look like crap to some people, but it's going to look fine to others. See this torque wrench here? This is an actual torque wrench. It's a real thing. Okay? Everyone should know by now that this is actually what my dad actually manufactured. He made this. He made this when he was in trade school. They taught him how to build this. Unfortunately, it's not perfect, but that's because, well, it is what it is. This is actually calibrated. A guy with a professional torque wrench, he put it against my dad's, and they cracked at the same loads. Exact same loads. This thing is calibrated, even though it has rust, you know, pit marks all through this bar, and that's the calibration for the thing. It's fine, and you can look how he's done it up the top. Look, he drilled holes, he filed it out square, and he pushed that thing in. And it doesn't look even perfect to me, but it does work. It's not perfect square, but it does work. It did work, and it does work. It does the job, and it has this special thing that when you push on that thing there, it releases the pin. My dad made this, and he made this 30 odd years ago, maybe even more than that. I'm pretty sure he's done it more than 30 years ago. That's when he done that. He's about 60 something. I don't remember how old he is. He would have learnt, been in trade school around 16, 18, so it's about maybe 40, 50 years ago. So he's got 40, 50 years of experience engineering. He does not have 40, 60 years. He doesn't have that many years experience working on engines and stuff. The only engine he's ever built with any success, and he makes it sound like he ran it, but he didn't, from what I can recall, this bastard here. He made the manifold up that's in there. This is a V8 351. Him and his dad helped him out with this, but the carburetors on top, his dad helped him set those up with all the fittings and fixtures and all that stuff. He aerodated the internals of this where the coolant would normally run on fuel. I'm not sure which one it was. But yes, he put that thing together. And look how nice it is. He done the exhaust manifolds, he painted them, painted the block blue. So that is what it is. And then there's a 351 in the back, which is stock. Because this one's a 400 and that's a 351. He has a C6 or C4 right there, spare. He has another one somewhere over here in the car. Been fitted because someone pressured him. Here's the thing. When you put under pressure, you do stupid things. My mum's brother put him under pressure to put the gearbox in. And he regrets putting it in now because it had a little bit of water go through it, maybe. The housing is now corroded a little bit. And he's not happy that he did. He wishes he never put it in now. He wishes he never gave in to the pressure. The thing is, when you put under pressure to do something, you make mistakes. You are likely to make mistakes. And that same pressure does run in the family, it seems. It's not just me when I'm put under pressure to do it. Because the pressure for me wasn't directly from anyone. It was from needing the car, needing it for work. I don't want to rely on anyone else but myself to get to and from work and do stuff. That's why that is so important to me. I don't want to be going to my mum to borrow her car every day of the week and then be put in a boat where mum needs her car back and I have to give her the keys and I can't go to work, and there's just too much stress with that and those scenarios. Like, how am I going to get around? I can use an Uber, but you know, they cost a lot of money to go to and from work. And then here you go, car that was running, shitty input shaft for the gearbox, and that's from apparently a rebuild prior, but okay, it is what it is. I can't really change everyone's opinions of me. I can't change everyone's perspective on what's going on, because some people are going to be so focused on the little details, the littlest things that they can pick on. If they can pick on something, they're going to pick on it. I'm in some ways used to understanding that that's how people are. If you don't like what I'm trying to achieve and what I'm trying to share and make the point that we're all making mistakes and we're all gonna make mistakes, then feel free to go and look at someone else's channel. I'm not fussed because I'm just doing this to be real. I'm a real person and this is a real scenario. I'm working on my own car and I'm learning things along the way, and I'm working a lot with the 4056T because I haven't got anything else to work with other than the ZL's 4.1 litre engine, which is in that car there. And why aren't we working on that car there? Because for me to work on that car is going to cost me a minimum of about $60,000 to get that thing on the road. That's in restored condition. That's in better condition than this thing will ever be. This thing will never have 60 grand spent on it. This thing has had between 10 and 20 grand, but I don't think it's nearly 20 grand. No way. But that's over its lifetime that I've owned it and driven it and worked with it and stuff. 7 grand motor. I don't know about the ZL. They say $1,000 to rebuild a ZL motor. Oh my gosh. This motor that's going in here, I already got a quote initially for just a rebuild. It doesn't include all the parts. It's just rebuild it and make it like new again, but it's not going to be new because they're going to reuse old parts. They said I'd probably need around about 7 grand to have them rebuild one. But this engine didn't come with all the goodies. I needed to obtain goodies that it didn't have to make it right and get things done. So I've spent $7,000. Now I'm at the point where if I really, really wanted to, it'd probably cost me another grand or two to have someone finish putting it together and calibrating it and tuning it and whatever and whatnot and getting it right. But at the end of the day, I've saved myself a grand or two by doing the work myself. The stress that comes with trying to keep your car running and trying to... This can be daunting, especially when you really need it. Especially when you're also in the position where you could have a job tomorrow, you couldn't have a job tomorrow. It's in a perspective where you could be a courier driver, and this little engine here is the same one in your car, and you never know when it's going to let go. It was reliably unreliable because it never broke down, and yet we knew there was problems with it. We knew there was problems with it, and it was just, we knew that there was going to be a problem somewhere down the line, that something was going to go. We knew it was going to happen. And that's why I've operated the way I have, been trying to let this thing just keep running, let it be unreliably reliable thing, and then build this one on the side and try to make this one as reliable as possible. Personally, the only thing I can see wrong with this is I should have done it as quickly as I could at one point or another when I had everything right, because by the time I had the head on, I shouldn't have had to ever take the head off again. But unfortunately, I rushed, and that's why the head came off again. And when I had to take the head off again, I made one mistake by not doing the pistons. And then when I did do the pistons, I made another mistake by letting some grit get into the rings, and then the grit, it did something to the walls of the cylinders, and it wasn't good. The greatest difference between this engine and the one out there in the car was that one's upper bearings didn't get changed. They're still the factory bearings. They got thousands of kilometers on them still. This one's all brand new bearings. There's nothing old about those ones. They're still the old con rods, brand new connecting rod studs, because those ones snapped. Those ones are still old in that engine. Okay? And they don't actually replace them. They reuse the old ones in the real world. Except when they do break, then they, swap and change parts to get them right and put them together, and hopefully they just hold up. That's essentially the hope, is they just hold up, and then hopefully nothing goes wrong. This one here has now the pistons polished. That cost about $60 just to polish the pistons. That's just in materials. So that's why I've just had enough of doing the pistons. The more aim for perfection, yes, but that's ridiculous how much it can cost you just to polish them, and then to get them perfect. Oh my gosh, I don't know. I can't even figure out where I'm going to get the grits from, because I haven't gone searching hard enough or tried to buy them yet. So haven't obtained any, so I don't know. When I obtain some, then I know how to do it, but I haven't yet, so I'm happy with this to an extent. Now, I'm actually confident in this bottom end. Right now, the bottom end is fine. There's an imperfection in the cylinders, yes. Very minute. It's not like it's going to cost me, the engine's not going to fail. It's not going to be a major issue. It's actually very, very minor. So I'm going to be able to get away with it. Because the other reason why there's scoring in the bores, crazy. That's the aluminum. When you put the pistons in, that's the aluminum rubbing on the sides of the walls. That's where the rings, that's where the walls have been scratched. And it's crazy that aluminum can scratch it, especially when it's polished. I can't believe that. So maybe there was some grit in the bore when I originally put them in, or maybe somehow something got in and did it. But now, 50% of those bores are perfect. The other 50% is very, very minor. And from something I read, you'll never ever get a bore perfect. And that's why in some cases they have those pistons with the coating on the sides, which is designed to rub off onto the walls to try and help build it up and perfect that surface. So where it is imperfect, it fills it up. And where it is perfect, it just goes away. It just rubs off. It wears out. They want it to wear it in some spots, and in some spots they don't want it to wear it out at all. But that it's coating to fill up the cylinder walls and perfect it. It's engineered to do that. And it's incredible stuff you can find out. But now I've got my 500 MLS gasket destroyed, and now I've got a $110 one right there ready to go. Actually, it's a $90 one, but you pay $20 shipping, and I bought two. So I'm going to send one off. And I think it cost me $220, I think. I'm going to have to leave it there, essentially. I've got to focus on this as much as I possibly can. I'm going to get, just in case, and I don't want to make mistakes, I need to make sure my dad understands the situation when we do look at this block. I need to make sure he knows that, yes, those MLSs are very fussy. And those surfaces need to be essentially what they say, perfect to an extent. You don't go too much or too little, you get just right spot. And I'm going to let him reassess my work, and we're just going to have to take a chance based on what he says. If something goes wrong, I'm just going to have to accept the failure and accept that, yeah, this is probably going to have to come out again. But the intent right now is, if this doesn't fail, I keep driving it. But when it does start failing, I'm going to throw additives in the system, because I'm going to think, screw this, I need my car, I'm going to do it. And what I'm going to do in the meantime, if that does fail, I'm going to fix this one up. I have a plan. It's not perfect, it's not flawless, but at least I have a plan, because I couldn't do this one the way I wanted to do it, and I needed an engine. There you go. I got a plan, I got a strategy, and when something does fail, that's when I'll fix it. It hasn't failed, it hasn't even run. I'm going to give it a shot. That's my intent, that's my plan. And now you know the whole situation, the whole scenario. I know I'm putting thousands of dollars of parts together, and I know it could screw me over by doing what I'm planning on doing, but I don't have many choices right now. This one here, we're just waiting for Dad to make a decision on whether he's going to rebuild this pump or not, because if he rebuilds it, the chances of this engine failing again is down, because the pressures will be corrected. If there's any inconsistencies, they'll be corrected. And if there's any issues with debris coming from the pump going through those injectors, it's going to be mitigated, it's going to be avoided, and it's going to avoid Dad having to spend thousands of dollars every time the injectors fail, or hundreds of dollars when the injectors fail. Just by fixing that, that will be a lifetime guarantee that this thing will last. Because it wasn't properly rebuilt. We looked at the paperwork. Someone spent $1,100 to have that injection pump overhauled, and the overhaul was essentially, and it was only, injector pump seals. There was nothing to do with internal guts of it. There was no testing or calibration. It was just rebuild the pump, replace the seals, and that was the end of it. They didn't do the job correctly. Because if you're rebuilding a pump, you should do it professionally. And this was an Outback bush mechanic. So, it is what it is. But that's my case in point. There is professionals that don't do proper jobs either. You can get away with some things up to a certain point, but beyond a certain point, it's not okay. In this case and scenario, that thing has to be done right because it's a diesel. It's a high compression. It has higher tolerance. I don't know whether it's high tolerances or lower. I think you need to have things nearly perfect when you do them. Nearly perfect. They don't have to be absolutely 100% perfect, but they do seem to need to be perfect. An engine like in there doesn't need to be done perfect because it's not a high power engine. Until they build it up, then things need to be done right. A composite gasket doesn't care about scratches. It will seal no matter what, so long as those scratches are not beyond a certain point or certain tolerance. You can sand the block and get it right just for the composite, but you can't do it for an MLS. So, thank you for watching, thank you for your understanding, guys. I'm just going to let you guys go. I got to focus on this and get this done, so I can put it in my car and go to work. My job now is working with cups, and it is assessing them and picking the good ones from the bad ones and making sure they're all good. So, take care everyone. I got to get ready for work. Bye.